One of the biggest mistakes a lot of people make when they first start learning how to read schematics is that they look at all the lines on a schematic and they immediately think to themselves, okay, which way is the electricity flowing on all these lines? Now, in most heating and air conditioning circuits, what we're dealing with is an alternating current. And what alternating current does is it actually moves in both directions along the same wire. So it moves forwards and then backwards, and it constantly oscillates back and forth. That's why they call it an alternating current. So when you're looking at a schematic, you're not looking for directions. What you're looking for is a complete path physically from the power source through the entire circuit and back to the power source again. So let me give you an example of what I'm talking about. So you can see right here we have our contactor. This is a schematic for an outdoor condenser unit. And on this contactor we have L1 and L2. So what we're dealing with here is 230 volts. We have two power legs. We're going to have 115 to 120 on each one of these legs. Now on this schematic, I should be able to start off on L1, trace through the entire circuit, and eventually find my way back to L2. And both of these power legs are coming from the electrical panel in the home. So this is our power source coming into the unit. So if I start off on T1 and I follow this black wire here, we trace it down, and we end up coming down to the common terminal on our compressor. We go through an internal overload switch here, and if I were to continue on, I go through my main winding on the compressor, and we find our way coming back out again on this red wire, and I make my way all the way back to T2. Now here I have a switch, all right? There is a gap between both ends of that switch. That means it's an open switch. And that is preventing me from making a complete circuit back to L2, which goes back to the electrical panel. So once this switch is closed, I then have that full path. We make our way back to the electrical panel, and we now have a complete circuit in which this current can now begin flowing back and forth on all these wires. Now, being able to look at a schematic from this perspective immediately gives you the gift of being able to use schematics to start troubleshooting problems based on symptoms you see. Because what a schematic does is it gives you a layout of what components or switches or items are in this circuit that can prevent that circuit from being complete, which prevents our current from flowing. So to give you an example, if we went back over the same circuit we just traced out, we go from L1 to T1 through this black wire, and we saw that we came to an internal overload switch on our compressor. All right, so that is a potential point where the circuit could be open. If our compressor is overheating, that switch will open and the current shuts down. Another point could be the winding in the compressor itself. Maybe that main winding is broken. That will open the circuit. Of course, we also have our switch up at the contactor itself. If the contactor's not pulling in, we're not going to have a full circuit. Now, this is where looking at symptoms can really help you narrow down from here. So, for example, if my condenser fan motor is still running, what that tells me is that this switch on my contactor is pulled in. That switch is closed. Now, through deductive reasoning, I can kind of start narrowing down that the reason why my compressor might not be running could be due to either this switch or the winding, but it's not going to be the contactor. And you can see how this begins to help us narrow down our initial testing points to see where the problem may be. Now, this is where understanding the difference between series and parallel circuits can really pay off, because this also helps you learn where to begin troubleshooting when looking at a schematic. Now, going back to the same circuit we traced over a couple times, we learned we had to go through our internal overload switch in the compressor, we had to go through our main winding, we had to go through our contactor to get from the power source through the circuit and back to power source again. Now, this is a series circuit. The current has to flow through each one of these components in order to get back to the power source. But if I were to trace out a completely different circuit, let's say we start off at T1 and we follow this black wire, and we find that this black wire brings us all the way down to our internal overload switch in our condenser fan motor. And just the same way, we go through our main winding and we follow this wire here, brings us to the common terminal on our dual capacitor. Now we have a red wire connecting to that same terminal, and when we follow that back, it brings us back to T2, which brings us through the switch into L2, back to our power source. Now that is a series circuit as well. The current has to flow through each one of these individual components to make its way all the way back. However, both circuits we traced out, whether it was through the compressor or through the condenser fan motor, are parallel to one another. So we have one series circuit for the compressor, one series circuit for the condenser fan motor, and both of these series circuits are parallel to each other. Now what that means is that we can look at our symptoms again, and this can help us figure out where our problem might be. So let's say, for example, we walk up to a unit and nothing is happening at all. What that tells me is if nothing is happening, there must be some common point that both of these circuits feed off of that's preventing them from being complete. So that, again, that could be our contactor. If that switch is not closed, neither one of those circuits are going to be able to get power. Now this could be due to a trip breaker, for example. So what this would tell me, if I have nothing going on, I might want to see if I have 230 volts between L1 and L2. Maybe I have a trip breaker. And if I do have a trip breaker, let's say I don't have voltage there, I find the breaker tripped. That's a good sign I might have a short in the system somewhere. Now once you're able to start figuring things out at this level, you can continue using the schematic to start troubleshooting from that point on. So let's say I do have a short in a circuit somewhere, it's tripping my breaker every time I get a call for cooling, but I have no idea where to begin looking for this short. What a lot of guys might do is, for example, they might disconnect this black wire here from T1. They will also disconnect a red wire here from T2 that feeds our compressor circuit. They'll turn the power back on, they'll initiate a call for cooling, and at that point, if our condenser fan motor starts up and our breaker doesn't trip, well, that tells me, okay, now I'm looking for a short in my compressor circuit. I might have a shorted winding on my compressor and so forth, and that's where I'll begin testing. If my breaker immediately trips again, well, I know, okay, well, maybe I have a trip in this condenser fan motor circuit, or maybe there's a wire touching ground somewhere. The troubleshooting and diagnostic gifts that schematics have just keep giving. So we're going to keep covering this stuff. We're going to keep making more videos. Hopefully we'll keep turning on more light bulbs for you guys. So thanks for watching.